Hi, today's lesson is on 6.7, modeling with exponential functions. So our essential question today is, how can you recognize polynomial, exponential, and logarithmic functions? So first we're going to talk about classifying data. And we have analyzed finite differences of data with equally spaced inputs to determine what type of polynomial function can be used to model the data. We used to do just like finding the difference, right? And so we were adding and subtracting our way. So for instance, like this one, I'm subtracting by 2, adding 2. And this one, I check first to see if multiplication works, but it doesn't because it's multiplying by 4 and then something else. This will be plus 6, plus 10, plus 14, and this one will be plus 18. And then hopefully you then see that the next line is adding by 4 every time. Sorry. And so since the second difference is constant, this is a quadratic function. Okay. Well, for exponential data with equally spaced inputs, the outputs are multiplied now by a constant factor, right? Because it's repeated multiplication. And these, thus, or therefore, consecutive outputs form a constant ratio. So now, when we take a look at this, I'm going to ignore the decimal. I notice that if I add 1, add 2, add 4, like we're adding by a different number, and no matter how many differences I find, it's not going to work because there's another pattern, which is times 2, times 2, times 2, times 2, and times 2. So you do have to sort of just look for multiplication first, since this is our exponential function chapter, right? So this is an exponential function then. And my rate, or my, what I'm changing by, my ratio is 2. Okay, danger with this r because it's not in like 1 plus r, this is just my ratio. So maybe I should write just ratio equals 2. What if you can't figure it out? Well, I can do 32 over 16, 16 over 8, right? And when I check those over 16, that should be equal to 16 over 8, right? And the 2, as we keep going down, are always the same fraction-wise. So now let's write exponential functions given 2 points. You know that 2 points determine a line. So now 2 points can also determine an exponential curve. So let's write an exponential function, y equals a times b to the x, whose graph passes through 1 and 6, or 1 comma 6 and 5 comma 50, 3 comma 54. So this is going to be my x1, y1, x2, y2. So what we're going to do is we're going to find we're going to plug this point into here, and then we're going to take a second one and plug it in, and then we're going to combine the two because there's an unknown variable. So let's take a look. My y, let's say for 1 comma 6, my point is going to be y equals 6 equals, I'm going to use this. I don't know a, but I know b. I don't know b either, but I do know x is 1. And so if I have 2 unknown variables, then I need 2 equations to solve a 2-variable problem. Okay, so this will be 3 comma 54, which gives us 54 equals a times b to the third. Okay. And so this is implied that both of these will be the same. So let's solve for a variable first. I'm going to solve for the easiest one possible, which is the one without exponents. You guys see how a is easier? So let's do that. And I'm also going to solve for the smaller one. Okay, so I'm going to here solve 54a. So that means 6 equals a times b, and I can divide by b on both sides, and I get a equals 6 over b. Well, let's see what we're going to do and continue. Okay, at this point we have a equals to b, but we don't know what b is, so we're going to plug this into our second equation. Okay, so let's take what we have here. I'll do it over here. So that's 54 equals a times b cubed. And I'm going to take a and replace it with 6 over b. Okay, one of these b's cancels out, so I have 54 equals 6b squared. Divide by 6 on both sides, that gives me 9 equals b squared. That means b equals 3. Remember that bases of exponential functions cannot be negative. Okay, so that's my b. I can start my function. Y equals, I don't know a yet, but I know b is 3 to the x power. Well, how do I solve for a? If you remember correctly, right here, we can now plug in b equals 3. So I have a equals 6 divided by 3, which is 2. And then I can plug in the 2 here. Okay. We cannot multiply 2 to 3. 2 is our y-intercept, our starting value. 3 is the multiplier or base, right? Or like not multiplier, but just our base. Confirm we're correct by finding the function using your graphing calculator. Okay, so this is where I'm going to teach you to quote-unquote cheat, but you got to be ready to show your work, because I don't really care about the answer. I want to see all the work in there. So we're going to go to Stat, Edit. Remember to clear your calculator. You're not going to delete a list. You're just going to clear it and hit Enter. And then go up, clear, and hit Enter. Okay. If you do end up deleting a list, please go to Stat, and then go to Setup Editor, and that'll bring it all back if you do delete it. Okay. So let's see. We have x is 1 and 3. Y is L2, which is 6 and 54. And now, if we hit Stat again, we're going to have our calculator calculate something for us. And we're going to go all the way down. And there's now exponential regression. Okay. So let's write a few things, just in case you needed it. Stat, edit, L1 is your x's, L2 is your y's. Okay, and then you need to stat calc. 2 buttons each. And then you're going to go to 0, which is EXP regression, exponential regression. Hit Enter. And that tells us that we have y equals a is 2, b is 3. And our r squared, which is our correlation coefficient, is 1. That means it is 100% accurate. Okay. Well, data is not always perfectly accurate, right? When the data is in a scatter plot, it shows sometimes an approximate exponential relationship, and you can model the data with an exponential function. So if you are trying to find a function algebraically, you need to pick any 2 points, okay, that are given. Now, will this give you the perfect equation? No, right? But like what you're going to do is pick the 2 that you need. So I want you guys to practice this, because this is exactly what we just practiced. So this is a great you try problem. And we're going to use, let's see, which ones do I want to use? Let's use 112 and 436. There's no reason I picked those, except that you sort of want to be a little further away rather than like right next to each other. So these are just the points we're going to pick. So 4. So can you guys take a moment, show your work, and try this yourself? I should probably warn you, it's going to be a decimal value. Don't be scared, okay? Leave it as a decimal. Okay, so in this one, you're going to end up needing to do a cube root of 3. And just remember that the cube root is 3 to the 1/3 power. And that gives us a decimal value, which we plug in, and we get a equals. You can use the decimal value. I like to use exact values. So I did 12 divided by root 3. What would happen if we did 12 divided by 1.44? I think that would give you a different number. Okay, and you see how like it's slightly different. So you get 8.33 instead of 8.32. In chemistry, this is not accurate enough. This is better. Sorry, this is not as good, right? So this one is better if you use this. Okay. Let's verify our answer using the graphing calculator. So when you do this, you need to input all the points and just do a check to see if you get y equals 8.46, 1.42 to the x. Okay, so try this yourself, please. And our last example is finding a logarithmic model using technology. And this one just wants you to use the graphing calculator to find the logarithmic model that represents the data. So can you please enter this into your calculator? Okay, so I'll show you one more time in case you need. Stat, edit. Air pressure is usually, like the first one is your x, the second is your y. So this is L1, and this second one is L2. So I'll do 1, and here's the thing, when you're doing things where you're entering data points, you have to put in all the numbers. Are you lazy and you don't want to? Yeah, probably, but you're going to do it anyways. And then 0, 5, 10, 15, 20, 25. Make sure they match, right? So I have the same number of x's and y's. And the only difference now is since we're doing a logarithmic model, we're going to go to stat calc. And this is 9, which is ln, sorry, that's a horrible n, ln regression, okay, which gives you y equals a plus, so it's 0.863 plus ln, I'm sorry, there's a b before our ln, it's a minus, right, because right here there's a minus, so minus 6.447 ln of x. Okay, you can see why I write ln instead of ln without the cursive, because this could look very much like a 1, and so I like to make it very clear that it's different. Okay, so it's all the same except you go to calc, ln regression. Okay. Now it says estimate the altitude when the pressure is 0.75 atmosphere. Well, if the altitude is 0.75 atmosphere, I'm solving for, estimate the altitude. So this is my air pressure. Now, even easier than I was thinking. So that's my x, right? Like I'm going to plug it in. And so technically I should change my variables. It does specifically say which variables to use. So we're going to do h for height, which is the same as altitude, p for pressure, and that helps us now. So I'm going to go height equals 0.863 minus 6.447 times ln of 0.75. That gives us 0.0863, oops, sorry, 0.863 minus 6.447 ln of 0.75. That's approximately 2.718. And what's the units? 718 kilometers. Okay. So you are 2.718 kilometers in the air when the air pressure is 0.75 atmospheres. That concludes our lesson for today. Tomorrow we'll practice with more word problems.